about Simpson 1/3 rule. So first we discuss theoretical concept, means how we find Simpson 1/3 formula, then error which is occur in a Simpson 1/3 method when we solve any numerical problem, then we solve a numerical example. So Simpson's 1/3 rule, 1/3 method, Simpson's 1/3 method. So first we give the geometrical interpretation of a Simpson 1/3 method. Suppose we have a n+1 ordinate, means in a x-axis x0, x1, x2, and similarly there is a xn minus 1, xn minus 2, xn minus 1, and xn, and corresponding values of a function with a y0, y0, and here y1, y1, and here y2, and in a similar manner here yn minus 2, yn minus 2, yn minus 1, and yn. So as we know that Simpson 1/3 method is under the category of a method based on interpolation. So here we use three values, means first we find the area from x0 to x2, then area from x2 to x4, x4 to x6, x6 to x8, then xn minus 2 to xn. Now question is what is the degree of a polynomial that be able to fit from y0 to y2. So here there is a three known values, y0, y1, and y2 between x0 to x2. So we know that nth degree polynomial of nth difference of nth degree polynomial is a constant. So with the help of a three known values only we able to find out a second order differences. So second order differences means a third order difference, fourth order difference onwards become 0. So with the help of a three known value only we able to find out a second order difference. If we able to find out a second order difference, then we able to fit only a polynomial of a degree 2, up to a degree 2. Means we able to fit a polynomial of a degree 2. From what? From x0 to x2, similarly x2 to x4. x2 to x4, suppose this one is x4, and in between x2 to x4 there is x3, again we fit a polynomial of a degree 2. In a similar manner, xn minus 2 to xn, xn minus 2 to xn, here we fit a polynomial of a degree, again suppose polynomial of a degree 2, this one. So between x0 to x2 we fit a polynomial of a degree 2, x2 to x4 polynomial of a degree 2, and x4 to x6 similarly xn minus 2 to xn. But it's not necessary always there is a polynomial of a degree 2 between x0 to x2, between x2 to x4. Maybe this one is a polynomial of a degree 3, maybe this one is a polynomial of a degree 4, maybe the function like this one, function like this one, function like this one. So what we find? We find this area. By the Simpson 1/3 rule we find this area. But what is the actual area? Actual area is this one. Actual area is this one. So we find this area, but actual area is this one. Then what is the error? Error is this one. This one is the error in a first iteration. Similarly, in a second iteration there is an error. If suppose function is like this one, then again this area is what? This area generates the error. So this was the error in a first step. This area is an error in a first step. This one is an error in a second step. Similarly, this one is a suppose error in a last step. So suppose this one is a what? Area in a last step. And if we talk about E1, E2, so this one is not En, this one is En by 2 like this one. So now this one is means we fit the polynomial of a degree 2, we fit this curve, we fit this curve, we fit this curve, we fit this curve. Now question is how we find this curve, how we find this curve, and how we find this curve. Once we find the mathematical equation of these curve, then we write the mathematical equation of these curve, then we able to find out a Simpson 1/3 formula. So now next we are going to derive mathematically what is the formula to find out the value of integration from x0 to xn by Simpson 1/3 method. Then we find the error after first step, error after second step, then error after last step. So what is this one is a word, this one is a geometrical interpretation of a Simpson 1/3. Now mathematically how we find mathematical derivation, derivation of a Simpson 1/3 method. So here we assume that I equal means here what is our need? Our need is to find out the value of integration y dx. Y dx means y equal fx being function that we are going to integrate from x0 to xn. And here we assume that this one have a in factor of our x0 to x2, x2 to x4, x4 to x6. So here x0 to x2 y dx plus x2 to x4, x4 y dx, x4 to x6, 6 y dx. Similarly, last one is a xn minus 2 to xn y dx. Now one by one we find the value of x0 to x2, then x2 to x4, x4 to x6, then xn minus 2 to xn. And suppose this one is the first one, I1, and here we assume that this one is the I2, and in a similar manner In by 2, because there is a n by 2 terms. So what is the value of I1? We find the value of I1 in a similar manner, we write the value of I2, I3 and last term. So this one equal x0 to x2, x0 to x2, y dx, and we know that we are going to interpolate a polynomial of a degree 2. So here we assume that these term means x1 have an unequal interval, equal class interval, x2, x0 plus 2h, means the difference between x1 and x0 equal to the difference between x2 to x1. Means we derived the Simpson 1/3 rule for the equal class interval. So x0 to x2 y dx. So here we write a what? We write a forward interpolation formula. So what we write here in a forward interpolation formula, because forward interpolation formula is an interpolating formula for equal class interval. So how many number of a term here we write? Here we write only a first 3 term, means up to order 2, because there is a 3 known values, so we cannot find means a third order difference, fourth order difference and so on. So this become x0 to x2 y dx. What is the formula? Formula with the y0 plus u del y0 plus u minus 1 of 1 factorial to del 2y0, and I am not going to write all other terms because del 3y0, del 4y0 become 0. So dx. So what we write here, this one in a function of a u, but here we are going to integrate with respect to x. So we cannot integrate like this one. So we convert this one in term of a u, and we know that what is the value of a u? U equal x minus x0 upon h. So what is the lower limit? What is the value for dx? Dx become h du, and what is the lower limit? Lower limit become, if we put x equal to x0, then u become 0, and if we put what is the upper limit, if we put x equal x2, so this become x2 minus x0 upon h, u equal x2 minus x0 upon h. So here x0 plus 2h minus x0 divided by h, this one cancel out, and what is the value for upper limit? This one equal 2. So just put here and simplify. This becomes 0 to 2, y0 plus u del y0 plus, if we write in a simplified form, this one is a u square minus u del 2y0, and dx can be replaced by the ht. Now if we integrate and h, we operate here h become outside, so this become h inside. What is the integration of this one? y0 u plus u square upon 2 del y0 is what? Here we write y1 minus y0 plus 1 by 2 here u cube upon 3 minus u square upon 2 del 2y0, and here del 2y0 can be replaced by the what? Using the shift operator. This one is a e minus 1 square y0, lower limit is the 0 and upper limit is the 1. So if we simplify this expression, what is the result? Here if we write one step more here if you see this one is a coefficient, so this one is a coefficient of u, so by putting lower limit all the term becomes 0. Only putting the upper limit we able to find out an expression. So what is the value if we put the upper limit? H means here not a 1, this one is a 2. So sorry, this one is a 2 because here 0 to 2. So here we put 2, u equal to 2y0 plus 2 2s are 4 by 2, this one is a 2, y1 minus y0 plus 1 by 2 3s are 8, 2 the power 3 is a 8 by 3 minus 2 2s are 4 by 2, this one is a 2, and e minus 1 chi square, this become e square minus 2e plus 1 y0. So if we operate this one, e square y0 become what? y2, e y0 become y1 and y0. So if we simplify this expression, what is the result? Now result become, if we write here, what is the result? Result become, we write the result become, if we simplify this one, I1 become, after simplification, this become h by 3 y0 plus 4y1 plus y2. So this one is a value of I1. In a similar manner, I took with the integration from x2 to x4. Means we replace the y0 by the y2, y1 by the y3 and y2 by the y4. In a similar manner, we find the value of I2 equal h by 3 y1, not y1 because here we start from y2 plus 4y3 plus y4. So in a similar manner, what is the last term? Last term become h by 3 means integration from xn minus 2 to xn minus 2 to xn become yn minus 2 plus 4 yn minus 1 plus yn. These are the values of I1, I2 means integration from x0 to x2, x2 to xn, x2 to x4, x4 to x6 and xn minus 2 to xn. Now we put these values in this expression, then we get the required means a formula which is a true for what? Which is a true for means how we find the values. This one is a true for what? This one is a true for what? Here we write, we put the values, then x0 to xn become x0 to xn y dx become what? Here we write the I1 means h by 3 y0 plus 4y1 plus y2. Second term h by 3 y2 plus 4y3 plus y4. In a similar manner, what is the last term? Last term is a h by 3 yn minus 2 plus 4yn minus 1 plus yn. So after simplification, what we get, if we closely observe this expression, then here y0 and y1 occur in one time. Here y1, y3 means a multiple of a 4 have a means a y1, y3, y5 like this one. y2 occur 2 times. Similarly y4 also occur 2 times. So what is the value of our integration? Means x0 to xn y dx equal h by 3 become outside, inside first and last term y0 plus yn plus 4 times of our y1 plus y3 plus y5 up to what? yn minus 1 plus 2 times of our y2 plus y4 up to what? Yn minus 2. So this one is a what? This one is a formula for the Simpson 1/3 rule. So if we underline this one, so this one is a formula for what? This one is a formula for the Simpson 1/3 rule. So, and if you write in terms of our words, h by 3 into sum of a first and last term plus 4 time of a sum of a odd term plus 2 time of a sum of a even term. So this one is a word, this one is a formula for the Simpson 1/3 rule. Now we are going to find out what? We are going to find out the error. Error in a first step, error in a second step, error in a third step, similarly error in a nth step. What is the benefit of this one? To find out error in a first step, error in a second step, error in a third step. When we solve any numerical problem, then we able to find out what is the error, what is the amount of error. Means if we solve with the help of a Simpson 1/3 rule, what is the error? So if we able to find out the error, then the result that we obtain with the help of a Simpson 1/3 rule, then add the error, then we able to find out the actual value. So that's why this one is important, why we find a error. One another important why we study the error means if we try to find out solution correct up to a 4 decimal places, then how we choose the correct means the value of h. What is the value of h? Because there is a different value of h. So here another thing that we need to emphasize here, x0 to x2 means n is always multiple of a 2. Otherwise, if this one is not a multiple of a 2, then you are unable to fit a polynomial of a degree 2. So always when you solve a numerical problem, always choose the value of a n, value of a and in multiple of a 2. In a trapezoidal rule, this one is a multiple of a 1. In Simpson 1/3 rule, this one is a multiple of a 2. And similarly, in Simpson 3/8 rule, this one is a multiple of a 3. So now we going to derive means what is the error? Means this value, what is the value for this one mathematically? What is the value for this one? Then we find the sum of all the error, and sum of all the error is nothing else error which occur means after solving any numerical problem with the help of Simpson 1/3 rule. So now we are going to derive what? Simpson 1 error in a Simpson 1/3 formula. So what is the error in a Simpson 1/3 formula? So it's not a very tough task. It's with the help of Taylor's expansion, we try to find out error which is occur in a Simpson 1/3 rule. Errors in Simpson 1/3 rule. Simpson's 1/3 rule. 1/3 method. 1/3 methods. So how we find this one? So first we write what? First we write error in a Simpson 1/3 method. We write Taylor series. What is the Taylor series? As we know that Taylor series is a y equal y0 means y0 plus x minus x0 y dash 0 plus y dash 0. If we write here not y dash 0 like this one, if we write y dash 0 here, x minus x0 ka whole square y double dash 0. Similarly, all other term, one term again we write x minus x0 upon factorial 2, x minus x0 ka whole cube upon factorial 3, y0 triple dash and so on. How many number of terms? There is an infinite number of terms in a Taylor series expansion. So this one is a Taylor series expansion about x equal x0. Means about x equals x0 we find a function, and that function is a what? That function is this one. This one is a function of x. So, but what's happen in a means we find the value for y1 and y2 with the help of this one. What is the value for y1? Y1 and y2, as well as what is the value of integration. So if we integrate this one, means integrate this one and try to find out this error. Means first we integrate from x0 to x2. So x0 to x2 y dx equal integrate x0 to x2, this expression, complete expression y0 x minus x0 y0 dash plus x minus x0 whole square upon factorial 2 y0 double dash plus x minus x0 whole cube upon factorial 3 y0 triple dash and so on. Here we are going to integrate with respect to x. So if we integrate this one with respect to x, so what is the value for integration? Value of integration, this one is a what? This one that we denoted by the I1 in a mathematical derivation. So this one is a I1. So I1 equal what? I1 equal, if we integrate this one, this become y0 x plus x minus x0 whole square divided by 2 plus x minus x0 whole cube divided by 3 means factorial 3 y0 double dash, this one is a y0 dash, and similarly x minus x0 to power 4 upon factorial 4 y0 triple dash and so on. What is the lower and upper limit? x0 to x2. So when we put a lower limit, all other term becomes 0, means x0 minus x0, this becomes 0, x0 minus x0, this one also becomes 0, this one also becomes 0. When we put x equal x0, except the first term. So after simplification, what we get? We get what? I1 equal this one, and if after simplification I1 equal, what is the value? Value become y0 x2 minus x0 after putting the lower and upper limit plus x2 minus x0 upon 2 y0 dash square plus x2 minus x0 का whole cube upon factorial 3 y0 double dash and so on. This one is the what? This one is the actual value of I1. Means integration from x0 to x2 with the help of a Taylor series expansion. This one is the actual value of I1. So here you may also simplify more by putting x2 minus x0, because this one for the equal class interval, what is the value of x2? x2 become x0 plus 2h. So x0 plus 2h, when we write x0 plus 2h, this I1 become, here we write I1 in at bottom for this one, I1, this one is actual value, means actual I1, actual value of I1, here this become y0, x2 minus x0 become 2h plus 2h का whole square by 2 y0 dash plus 2h का whole cube upon factorial 3 y0 double dash and so on. This one is a value of actual value of this system, means from x0 to x2. This one is the actual value. Now we find approximate value, means that we obtain with the help of Simpson one third rule. Then we find the difference with this one. So now we try to write the what? We try to write the approximate value, means with the help of a Simpson one third rule. So with the help of a Simpson one third rule, what is the value of I1 that earlier we derived? The value of I1 is h by 3 y0 plus 4y1 plus y2. So here, how we write the value for y1 and y2? Again we write the value for y1 with the help of a Taylor series expansion, and also we write the value for y2 with the help of a Taylor series expansion. How we write the value for y1? We write the value for y1 by putting x equal what? X equal x1, means a Taylor series expansion about x equal x1. And how we find the value for y2? Taylor series expansion about x equal x2. So here we put x equal x1, then we find the value for y1. If we put x equal x2 here, then we find y equal y2. So what is the value for y1? Y1 become, here with the help of this one, y1 become y0 plus x1 minus x0, y0 dash plus x1 minus x0 whole square upon factorial 2 y0 double dash plus x1 minus x0 cube upon factorial 3 y0 triple dash and so on. So x1 minus x0, because x1 is a what? For equal class interval, this become x0 plus h in a similar manner. So this become, after simplification, y0 plus h y0 dash plus h square upon factorial 2 y0 double dash plus h cube upon factorial 3 y0 triple dash and so on. And similarly, what is the value for y2? y2, in place of x we write a what? x2, and after x2 minus x0 become what? 2h. So directly here we write, means we put x equal x2 minus x0 and x2 minus x0 become what? 2h. So here directly we write, after simplification, y0, this become 2h y0 dash plus 2h square upon factorial 2 y0 double dash. So y0 double dash and y0 double dash, and similarly 2h का whole cube upon factorial 3 y0 triple dash and so on. So now putting the value for y1 and y2 here in this expression, y1 and y2 here in this expression, then we find what? Then we find the value of what? Here. We put the value for y1 and y2 here, then we find the value for I1 equal h by 3 y0 plus 4y1, this one 4 y0 plus h y0 dash plus h square upon factorial 2 y0 double dash and so on plus y2 means this value y0 plus 2h y0 dash plus 2h the whole square upon factorial 2 y0 double dash and so on. So this one is a what? This one is a approximate value. This one is approximate I. Approx value. Approx interior, right? Approx value. This one is a approx value and this one is a actual value. And if we denote this one is the equation number 2, this one is equation number 3, and Taylor series is the equation number 1. So difference between actual and approx is a what? Error. So if we find the difference between equation number 3 and equation number 2, then we find the what? Then we find the error. So what is the error? If we write the error directly, means after simplification, what we get? We get the error in this step, E1. What is the E1? E1 is the what? E1 is the actual value for I1 minus approx value for I1, means equation number 3 minus equation 2. Equation not equation means actual value means equation 2 minus equation 3. So after simplification, this become E1 equal minus h2 power 5 upon 90 y0 4 dash. So minus h2 power 5 90 y0 4 dash. This one is a value for what? This one is a value after this one. Okay. So E1 equal minus h2 power 5 90 y0 triple dash. This one is a value for what? E1. This one is a value for E1. In a similar manner, what is the value for E2? E2 equal minus h2 power 5 by 90 into y2 4 dash, means here if we write not a 4 means a 4, y2 4 dash, 4 time differentiation. Similarly, we find the E3 and E6 and so on. So what is the error? Error, if we find the mod value for error, mod value for error is the what? Mod value for E1 plus mod value for E2 plus mod value for E3 up to mod value for E2n minus 2. So E2n minus 2. So what is the, after simplification, what we get? We get here the mod of a E equal h to power 5 by 90 y04 plus h to power 5 90 y to the power 4. Similarly, h to power 5 90 y n minus 2 to the power 4. So if you find the sum of this one in a similar manner, this one is a mod, this one is a mod, because here we are taking the mod of this one, okay, using the property of a mod. So we may also write this one in this way: E is a less or equal to h to power 5 m upon 90. where m is a what? M is a m equal max value of y0, y04, y04, y24 up to yn minus 2, 4. Means modulus value for this one, modulus value for this. Means maximum value for y04, y24, yn minus 2, 4. Then we find the what? We find the value for m. Or you can say means this one is the max value of a fourth order derivative in a given range field, means from x0 to what? Xn minus 2, xn. So if we write in this way and we try to write in term of what? In term of we know that what is the value of n? H equal what? X minus x0, and in case of Simpson 1/3 rule, n must be a multiple of 2, means a 2n. So here then what will happen here? N equal, if we write this one n, so here n also, because we find the sum of this one 1, 2, 3, 4 this term, so this one is n. Sorry, here I forget about this one to write n. This one is n. So how we replace the n? N can be replaced by the what? X minus x0 upon twice h, by this one. So if we replace n by the x minus x0 upon 2h, and n must be a multiple of a 2 here, due to this reason here we write the 2n. So what is the value for n? N become x0, so E is less or equal to what? Less or equal to, in place of n we write xn minus x0, xn minus x0, xn minus x0, xn minus x0 by 2h, means 180 into h to power 4 m. This one is a what? This one is the error. Value for error occur in what? Occur in. So this one is a what? This one is a error which is occur in a Simpson 1/3 rule. So to solve any numerical problem, there is a need to remember, means a Simpson formula for Simpson 1/3 method. Then what is the error occur in a Simpson 1/3 method when we solve any numerical example. Now we take one numerical example and try to solve how we find the solution with the help of a Simpson 1/3 method, and what is the use of this expression, means the use of this error. So now we are going to solve one numerical example based on a Simpson 1/3 method. So Simpson 1/3 method, this was the problem. Find the value of integration from 0 to 1 ex dx by Simpson 1/3 method, correct up to 5 decimal places by proper choice of h. Means what is the value for h that we choose, so that we able to find out this value of integration correct up to 5 decimal places. Correct up to 5 decimal places. So first there is a need to choose the value of h, and also we know that h also means n is also a multiple of 2. So how we choose the correct value of h, proper choice of h. So we know that error in a Simpson 1/3 rule, mode of error is a less or equal to xn minus x0 upon h to power 4 180, sorry, h to power 4 here, h to power 4 180, this way is a, sorry. So this one is a mod value of error. So mod value of error less or equal to xn minus x0 h to power 4 and 180. So what is the here? Here there is a need to find out a value of h, and e is a what? Correct up to 5 decimal places. Then e means the error, e must be less than what? Less than 10 to power minus 6. Correct up to 5 decimal places, then less than 10 to power minus 6. correct up to 1 decimal places, means 10 to power 2 minus 2. So here equal sign, due to this reason this one is a 10 to power minus 6, otherwise this one is a 10 to power minus 5, correct up to 5 decimal places if this one is a less than only. So E must be less or equal to 10 to power minus 6. What is the value of xn? Xn is a what? Xn is a 1, x0 is a 0. Means lower limit with a 0, upper limit with a 1. What is the value of m? Y is a what? Y equal e to power x, y dash is a e to power x, y double dash is a e to power x, y triple dash is a e to power x, and y 4 dash is a e to power x. So what is the m? M is a how we find the value of m? M is a m equal max value of y triple dash mod of y 4 dash in what? For means the values of x lie between 0 to 1. So what is the max value? E to power 0, e to power 0.1, 0.2, 0.3, and what is the max value? So max value in this case become m equal what? E to power 1. At this point, in this class interval, at this point means at 1, the value of fourth derivative become what? E. So this one is the value of E. Now be able to find out the value of m, be able to find out the value of E, means E is what? 10 to power minus 6, x and x0 we have. So be able to find out the value of what? Be able to find out the value of h. Now how we find the value of h? We put all the values. So here if we what? H, here we write E, it must be less or equal to what? 10 to power minus 6. So E, here we write E, xn minus x0 less or equal to xn minus x0, xn minus x0 become 1 minus 0, h to power 4 divided by 180 into m. So h to power less or equal to what? Less than 10 to power minus 6. So now if we simplify, because the value of E is less than 10 to power minus 6, 10 to power minus 6. So now if we simplify this one, h to power 4 m is less than 10 to power minus 6 into 180, and then h to power 4 is less than 10 to power minus 6 into 180 divided by m. And what is the value of m? The value of m is E. So what is the value of h? Value of h less than 10 to power minus 6 into 180 divided by e to power what? 1 by 4. So after simplification, what is the value for this one? After simplification, the value for this one is a 0.148. H 0.148. So with the help of this expression, be able to find out what? Be able to find out the value for h. What is the value for h? H must be less than 0.148. If h is less than, means this value, h must be less than 0.148, then be able to find out the value of integration correct up to 5 decimal places. So this one is a what? This one is a use of error, formula of error. So for this one we decide that h must be less than 0.148. So for sake of simplicity, we consider what? 0.1. So 0.1, if we consider 0.1, so how many number of factors here? How many number of parts here? There are 10 parts. Then obviously this one is a multiple of 2 also. So we are able to find out the solution. So what is the value for x0? So x0, here we write the x, here we write the x, here we write the value for y. X be the what? 0, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9 and 1.0. These are the values of x. What is the value of y? E to power 0, e to power 0.1, e to power 0.2, e to power 0.3, e to power 0.4, e to power 0.5, e to power 0.6, e to power 0.7, e to power 0.8, e to power 0.9 and e to power 0.1. So e to power 0 become what? 1. So if we write this one what? This one is the value for y0, y1, y2, y3, y4, y5, y6, y7, y8, y9, y10. These are the values of x0, x1, x2, x3, x4, x5, x6, x7, x8, x9, x10. Now, by the formula of a Simpson one-third method, formula of a Simpson's one-third method, what is the value? Value become here what? x0 to xn means 0 to 1 e to power x dx equal h by 3 inside y0 plus what is the n? y10 plus 4 time of a what? 4 time of a y1 plus y3 plus y5 plus y7 plus y9 plus 2 time of a y2 plus y4 plus y6 plus y8. So this one is a what? This one is a value of a approximate value of a this integration with the help of a what? With the help of a Simpson one-third method. So what is the value? If we put the values of a y0, y1, y2 up to y10 here, then what is the value of integration? Means approx value approx 0 to 1 e to power x equal what? Here we put these values. H by 3 means h is a what? 0.1 by 3 in bracket means y0 be the what? E to power 0 be the 1. 1 plus 10 means e. 1 plus e plus 4 time of our what? E to power 0.1 plus e to power 0.3 plus e to power 0.5 plus e to power 0.7 plus e to power 0.9 plus 2 time of a e to power 0.2 plus e to power 0.4 plus e to power 0.6 plus e to power 0.8. After simplification we get what? We get 1.71823. Now what is the actual value? If we find the value of integration, the value of integration become what? If we write the actual value here, actual value of integration, we know that 0 to 1 e to power x dx equal, what is the integration of e to power x? E to power x. E to power x 0 to 1. So this become what? E minus 1. E minus 1. What is the value for this one? Value for this one I have already noted down the value for this one. 1.71828281883. 8183. This one is the actual value. This one is the actual value. This one is the actual value. This one is the what? This one is the approximate value. This one is the approximate value. So if we closely observe, this one is a correct to a what? 71828. 71828. This one is also a 7182. This one 7182. 71828. 7182. 8283 like this one. This one is the actual value. 718283. So this one is a correct up to a 5 decimal places, and this one is a also means up to a 5 decimal places. This one is a value 1.71828. This one is a value 1.71828. So what is the summary of this one? If we try to find out means value of integration correct up to 5 decimal places, then the value of a error, mod value of a error must be less than 10 to the power minus 6. If we try to find out means correct up to 7 decimal places, then value of a error must be less than 10 to the power minus 8, 1 greater. So with the help of means this information, we able to find out the value of h. Means h may be a factor of a 2, maybe any value which have a factor of a 2. Maybe here 1 to 2 means there is a factor of a 2, means a 0 to 0.5 then 1. There is a 2 factor, 2 parts. So what is the value of h? And we know that as h is a small, then accuracy will increase. So h is larger, then the error is also a larger. H is small, then error is also a small. So with this information means we try to find out value which is correct up to 5 decimal places, then we find the value of h. H must be less than 0.148. If h is less than 0.148, then we able to find out a correct value up to 5 decimal places. So with this information we find the value of h. Once we find the value of h, then we write the value of x and y in a means for different ordinate, means in an interval of 0.1. Then we find the values of y0, y1, y2 up to y10. Then we, with the help of a write a Simpson 1/3 formula, once we write the Simpson 1/3 formula, and after calculation we write we find the approximate value of integration with the help of a Simpson 1/3 rule, and we know that what is the actual integration. By integrating this one, then we able to find out this one. So by comparing, if you compare the result, then you see that this one is a correct up to 5 decimal places. So this one is all about Simpson 1/3 method. In the next lecture, we will discuss about Simpson 3/8 method. This one is analogous to what? Analogous to Simpson 1/3 method. Thank you for watching my video.